Welcome to Berries in the Interim podcast, where we explore the cutting edge of innovative clinical trial design for the pharmaceutical and medical industries, and so much more. Let's dive in.
Welcome everybody back to In the Interim. I'm your host, Scott Berry. I have a really interesting guest today. I will introduce him, but I want to mention this podcast is jointly sponsored by the ASA and the Journal of Statistics and Data Science Education. Today, we're going to talk with Jim Albert. Jim Albert is an emeritus professor from Bowling Green State University. He's done an incredible amount of really cool work in Bayesian, statistical computing, and sports, and statistical education. And so we're going to talk today to Jim about teaching statistics using sports. Welcome, Jim.
Thanks for having me.
So my interest in statistics largely grew out of sports, watching sports, understanding the game, forecasting its strategy. I even to this day, much of what I do in clinical trials, I tie to sports. What's your introduction to sports, your introduction to statistics, and the tying the two together?
Well, I grew up in Philadelphia suburbs, and I always liked sports. I mean, I always was a baseball fan, and I played a number of sports. I liked basketball. I tried baseball, wasn't real good at it. I was born in a tennis family. I played a lot of tennis. And so it was sort of, and I always was good at math, although I didn't know what that would eventually lead to. And so, I played baseball simulation games like Stratomatic and All-Star Baseball, and I kept stats in our basement, and I typed up, I kept records in games, and I had standings and things like that. So, I think long ago I was trying to combine my interest in math with my interest in sports.
And you still play tennis to this day?
Yeah, I'm very lucky.
Still competitive.
My followed up, and the U.S. I have a lot of local people my age who like to play, and I'm still active in USTA, which is the tennis association. We have leagues, and it's fun. Yeah, it's a nice. That's how I exercise. So I play tennis.
Yeah, very good. So Jim is a distinguished university professor at Bowling Green State University. He's won the Founders Award from the American Statistical Association, Fellow of the American Statistical Association, won the Contributor for Statistics and Sports Award. So that's sort of the backdrop of all of this. When did you start? And go back to when you started doing statistics in sports. It was an incredibly different era than now. Now sports analytics is huge, but you started doing this long before this was an industry.
Well, I was sort of lucky because obviously I got hired at Bowling Green. That was my first job. In fact, my only job in academia. And really, honestly, although I like sports and I could think of good ways of applying statistics, that was not the way. Writing sports papers was not the way to get tenure.
Yeah.
So obviously, I started doing Bayesian research. I would throw in some baseball examples as illustrations, but I never really focused on sports problems. But once I got tenure, then I started to think a little more. I wasn't really in a consulting environment. So when I was thinking about applying Bayesian methodology, I just naturally thought about sports as the application. So then I started writing, and of course, I got to mention your father, Don Berry, was someone I really thought he did a remarkable work in Bayesian statistics, but also he loved sports, and he often used sports to illustrate statistical thinking. We had him speak, in fact, at a meeting in 1987 at Bowling Green, where he talked about, about problems in sports, in using stats.
Yeah, and I think that was a banner year, 1987, where the Minnesota Twins won their first World Series, which was a great year. So numerous articles in baseball, Bayesian. Let's talk a little bit about teaching. Did you, when you started teaching, was it something that you did a lot of sports examples? Was something I did. So initially in teaching, you brought in sports examples. Is that the introduction to the tying together the education with sports?
Well, I think sports is a natural way of talking. I mean, I think the nice thing about sports is that people understand, a lot of the students understand the context. And so I think, especially intro stats, where they don't really understand why statistics is useful, but they do understand things about sports. And so I thought, well, I said, well, why don't we make the course? I mean, since the students don't quite follow the applications we thought might find interesting, why don't we just devote the whole course to sports? And so I developed a baseball version of intro stats course. And that was a fun course. Unfortunately, I didn't get to teach it a lot, but I got to write a book. I got an NSF grant for it. And really, it was fun because you would walk in and you would just talk sports. You would just talk baseball, and you would introduce the students to historical people like Babe Ruth and Barry Bonds and Whitey Ford and Sandy Koufax. And, and then you always would bring in statistical ideas, but that never was you would always talk in the context of sports. And I think it's funny because students afterwards thought the course was useful, which of course is a little silly to say because talking about baseball. I think what they were saying was they really understood a little more what we were talking about because we were doing it in the context of baseball.
Yeah, and I part of it is the real application. Statistics can suffer from talking about urns and spinners and dice and flipping a coin, but to have a real application where you're talking about the difference between a parameter, the intrinsic ability of somebody as opposed to their data, and all of those parts, I always found it was and it was, as you described, most people understand it. There's always the issue of culture in the different sports. And, if you're talking about, is bunting a good strategy? Do people understand the sport and all of that? But partly the passion that comes with sports, and partly the clarity to which you can explain so many sports concepts, so many statistics concepts in sports.
Yeah, I always think, there's certain issues in sports like talking about clutchability, for example. People love to talk about that, or they're so excited about streaks, streakiness and performance. And so I guess that raises the issue of what does that really mean? I mean, for example, I understand there are clutch performances. Somebody hit a home run with the bases loaded in a ninth inning of a game, but does it mean that person has some extra ability to perform better in the clutch? I once talked to Tom Tippett, who created a baseball game called Diamond Mine Baseball. And I asked Tom, does he believe in clutchability? He says, no, but my people who buy my game want that to be part of the game. So he has to put in the clutch ability button or something, which, because people want that. People believe in those things, even though there isn't much evidence to suggest there is clutchability in sports.
So even Stratomatic added that at one point to it, where 2 outs, bases loaded, clutch situation, that it either added or subtracted hits from it. So I think the audience would be really interested in this. And one of the initial papers that I think you wrote was on streaks, and I think one of your heroes, Mike Schmidt, you were very interested in whether or not he was a streaky home run hitter. So explain the difference, and do you think Mike Schmidt was a streaky home run hitter?
Well, I don't know. I think what's interesting is that if you look at Mike Schmidt, his pattern, the way he played, the way he swung, I think it was a bit different through his career. I think he had bigger swings at the beginning of his career, and then later on he realized he didn't need to swing as long to get his home runs. And so I think you saw a little bit of that so what you looked at was the number of plate appearances between between home runs. And that seemed a little more irregular, I think, in the early part of the season. And later on, it was a little more, the gaps weren't quite as extreme. Now, what's interesting is that Henry Aaron, great home run hitter, he didn't have streaks or have long streaks, but he was considered more of a line drive hitter. So he didn't really hit up with this big uppercut that people like Kyle Schwarber now hits. But what was interesting, so when you look at Herring, there doesn't seem to be a big pattern of streaks. So I think there is something going on there, but I think it's a very subtle effect. And I think it's hard to view these things because there's so much chance variability or coin tossing variability that's making it much harder to see.
Yeah, and it's one of those topics in teaching a course that I find once you bring it up, of course, the rest of your hour or hour and a half, you're talking about this topic, but it's such a neat demonstration of randomness as opposed to signal. And it's one of the examples that I do sometimes is I put up a sequence of zeros and ones, and then you put up random sequences of random zeros and ones, and you ask people which one is the human putting up zeros and one, and which one are the random one. And invariably, when you ask somebody to write down a sequence of random zeros and ones, it goes 0, 1, 0, 1, 1, 0. Yeah, there are way too few streaks.
Right.
So the natural variability of a coin flip, if you show that to people, they say your coin is streaky. And it has momentum at different times. And so thinking about the game, how often do we attach that? I have a buddy of mine who loves to follow the win probability that's being posted now in games, in the NBA basketball games. And he sends me all kinds of examples of where a team has a 98% chance of winning and then losing, and the streaks aspect of it. So it's understanding that it's such a great example in class.
Right. I think I had a student who was collecting, we were collecting like in college basketball games, we were collecting the actual, streaks of performance. And it's remarkable that of all the momentum shifts you see in sports. And again, the question is, what does that mean? I think a lot of it is just sort of a natural kind of randomness. It doesn't mean that these players are suddenly getting, but of course you play a video game and, a person is hot and they put a big, some fire on his head.
Right.
He's in a different mode or something. But, and people love to believe that. It's a great story. It's great to talk about.
Yeah. So another topic you've written quite a bit about, and I guess I'll introduce it by saying it's May 20th, and Aaron Judge is hitting 401 on May 20th, 2025. What do you think Aaron Judge will hit by the end of this, assuming he plays a full season? What do you think his batting average will be at the end of the year?
I'm guessing it'll be about 320. The point is that, and this is just a empirical observation, that people's batting averages at the first part of the season tend to be very variable. And I just read that on the Nationals, Josh Bell is hitting like 150 or something. He's like the worst regular player now in baseball. Certainly he's been struggling, but he's going to get better. It's going to catch up. Likewise, Aaron's not going to get maybe as lucky with his hitting. And so baseball batting averages we'll never see a 400 hitter again in baseball for a full season. That's not going to happen. I think there are too many variables that are, in terms of strikeouts, for example, that are just, I will hurt someone's batting average. But him to hit 400 even for this part of the season is still pretty remarkable.
So this also is an intersection between sports, teaching statistics, regression to the mean, and Bayesian. It's such a natural Bayesian hierarchical model, and Carl Morris was the first to sort of show this. It's one of the examples I've taught actually sessions that are what drug developers could learn from sports. And this regression to the mean is such an incredible concept in sports that drug developers, it's such a important thing about forecasting what happens from a phase 2 trial to a phase 3 trial within its subsets. And it's such a natural thing in sports that people generally understand.
Yeah, another thing that's interesting is that it really depends on what you measure. I think a batting average, for example, is remarkably chancy. I think there are so many things that influence that. The balls that are put in play, it's a lot of luck involved. So I think some measures like batting averages are very chance-driven, while other measures like strikeout rates, those tend to be a little more stable. So I think a lot of it in baseball is understanding, which measures are predictive of future performance and which ones are not. And even though we love talking about batting average, it's a pretty crummy measure for predicting the future.
Yeah, and interestingly, over the time in which you've been studying sports, batting average when you started doing this in the 90s was kind of the stat, and now it's largely discounted in part because of analytics. And the value of batting average as opposed to on-base, slugging percentage, OPS, all of these other measures. As analytics has become huge in baseball, but all sports within that. And there are some that think that this has been a negative. What is your take on the explosion of analytics? And I guess I say this to the extent that, well, you wrote for some 40 years about statistics in sports. You did education. You are now employed by a sports team, the Houston Astros. And so you are part of this analytics for better, for worse.
Yeah, for example, fielding. I think in the old days, all we had pretty much was number of opportunities and errors, number of errors. And we now know that those are relatively, especially number of errors are really very subjectively scored. But now we have a lot more understanding about fielding because of analytics. We know, where you were in the field. We know, how the fielder was moving toward the ball. We can talk about things like catch probability. So I think now we can measure fielding. And to me, that's exciting. I think, to me, we're just learning more about the game. It's not taking things away. It's actually adding a new dimension to the sport.
Yeah. Yeah. So maybe a little bit about working for the Astros and implementing many of these Bayesian ideas. How is that going?
Well, it's going well. I think the reason why teams are more interested in Bayesians is because they understand the point is these teams are getting much more analytical. They're building up their groups. To me, what's exciting is that these groups are all basically young people, all from different majors, but they all have a passion for baseball. So you have a lot of very smart young people working for these teams, and they're just trying to, get better in terms of predicting future performance. A big thing, the AAA, which is the highest level of the minor leagues, is still a very different environment than major leagues. So there's so many things that affect baseball stats. You can talk about the opposition, you can talk about the pitching, you can talk about the stadium. Whenever you think about like Phillies last night played in Coors Field, well, Coors Field defines ballpark effects, right? Because they always talk about them there. Well, the minor league parks have their own vibe.
Yeah.
And so to me, I think teams like the Astros have to properly adjust, the minor league measures, because obviously they want to predict, how these players will do when they go to majors. And I think that's a big part of what they're doing, is understanding that process better.
Yeah. And now understanding a prospect that's in college, a prospect that's in minor leagues, a prospect that's in high school. I imagine all of that is trying to put these prospects on a similar scale. Who's better is fascinating.
Yeah, I think college stats and high school stats, those are very hard to make sense of because
Yeah.
there's so many variables, other variables that are influencing those stats. And again, and it's also they're playing against other players, high school players or other college players. And so you have to somehow adjust for that too.
Yeah. I've also loved the parallel of some of continuous sports like ice hockey or even soccer, where they now know where a player is on the ice every, tenth of a second. And they've got this amazing data of where the puck is, where every player is continuously throughout a game. But largely, I don't know if we really know what to do with that yet. And in clinical trials, we now have wearables, for example, where we have an enormous amount of data on individuals, their biomarkers, their behavior, their gait, you can judge cognitive ability by how they use their phone. But we have no idea what to do with this in clinical trials yet. It's almost this continuous amount of data that sports has to deal with, and it's a very different thing. But clinical trials and health, we've got to, what does it all mean at the same time?
Yeah, I think it's exciting because I think soccer, of course, that's the number one sport in the world. And really, honestly, what happens in soccer is not the scoring, it's the movement of players, right? I mean, I think that's really where teams get advantages. Like, I'm a tennis player, so I know the importance. I mean, when you get older, movement is not as obvious, not as easy as when you're younger. So I always talk to my tennis friends, and it's not about hitting the ball. The problem is getting to the position where you want to get a comfortable swing, get a good swing. And it's still, I think this is exciting. And I think for people that want to go into these professional sports who have statistical trainings, especially in spatial modeling, I mean, this is a wonderful opportunity for them because of that, that modeling is very useful in those sports.
Yeah. So over the course of your career, this was about teaching statistics, teaching data science, teaching the concepts through the applications through sports. Individuals interested in that may get passionate about statistics. That was my interest in math and statistics. I was a hockey goalie, and I could sit back and think about the analytics of ice hockey at different times because I had good breaks in a hockey game, and it was very much my interest in it. But now this is an industry. Now there are people that their career are sports analytics. They do this professionally. There are training programs in college. So you've seen this go from an application to teach statistics and data science to this is a field that people are going into.
Yeah, I'm getting more inquiries from students who want to work for a baseball team or work for another sport. And I tell them, I basically go for it. I mean, I think I can speak in terms of baseball. There are more opportunities to present your work. For example, one illustration example is Sabre Seminar. This is a conference that's held every summer. It's currently being held this summer in Chicago. And the point is to allow college students and high school students opportunities to present their work. And a lot of the baseball teams are represented at this meeting. So it gives a great way of connecting, professional people with these young people. And there are internships available. Teams are always expanding. It's just, I also went to Sabre has a meeting in the Society for American Baseball Research has a analytics meeting in spring in Phoenix. I was there this year. And I saw a lot of young people, they got special competitions for students. So I think if the students have the passion and they have the ability to communicate and put together like little projects, they really have good opportunities to get jobs for these teams.
Yeah. So suppose suppose there's somebody out there that's a sophomore in college and they're interested in this. They're interested in sports statistics, sports analytics. What skill set should they focus on as an undergraduate and then maybe even a potential graduate program? What are their important skill sets?
Well, they need some background in statistics, and that includes some experience in modeling. And of course, modeling can be a regression, of course, is a good step, but then obviously there are extensions of that, like generalized additive models, spatial models, but some experience in statistics. They need some, background in the sport, like either they could be working for a team, a college team, or they could be, have an internship or something. I think the ability to communicate what you do is so important nowadays, because I think it's one thing to do your own analysis, but to me, it isn't valuable unless you can explain to somebody who maybe is more of a decision maker, may not know the statistics that well, but they want to see what are you doing that's useful to what we're doing. So I think the ability to do that is pretty important.
Yeah. So statistical inference, statistical modeling, presumably there's programming, the ability to program, ability to handle data, because now the explosion of data, but then the ability to communicate, all of those things together is the focus.
Yeah, I think even what's interesting is that we taught a course in data science at Bowling Green, which a lot of it was coding. And I think it's one thing to code, but you want to code with a purpose. And I think David Donahoe had a book about about the growth of data science. He said a great thing to do, but if you're interested in baseball, is put together a book like, I have a book co-authored with Max Marchi and Ben Ballmer on analyzing baseball data with R. Well, that tells you about the data and it teaches you R, but then get exposed to some of the baseball problems. Tom Tango co-authored a book called The Book, which is basically describes a lot of interesting baseball problems. And so if you put the data science knowledge together with understanding some of the important problems in the sport, that's a good combination.
Yeah, nice. Is there was there ever a downside to teaching, using a lot of sports examples in teaching stat? Well, go ahead.
Well, I don't think people understand baseball, for example, that well. So even if you're talking to a bunch of football players, I think baseball, it's sort of it's a hard sport to watch if you're not familiar with the rules, because a lot of it is the encounter between the pitcher and the batter. And if you aren't aware of the different pitch types, and all those small things that are happening, it was much like I spent a year in England and I watched a game of cricket and I had no idea what was happening. I mean, it was it was even harder to me in baseball because the action was in the middle of the field. It wasn't near the stands. Yeah. And so likewise, I think baseball, you need to obviously explain the sport well enough so that people appreciate what you're doing.
Yeah, I was in the UK and I was watching at a pub cricket. I said, "This is amazing." Everybody says it's kind of dull, and somebody said to me, "You're watching a highlight show." I had no idea it was a highlight show as opposed to the action of it within that. So now you're working for the Astros, you're continuing, you also have an interest in potentially a journal for sports applications, and partly concerned about the accessibility of the work that's being done.
Well, right now, if you publish a paper in sports, the main outlets are the Journal of Quantitative Analysis of Sports and the Journal of Sports Analytics. Those are the two main journals that focus on statistical applications in sports. The problem is that they're both owned by companies and they really have a payroll wall behind those. So anybody who wants to read these papers is not able to read them. There's cost involved. And that, I think, so now there's a movement among the people, my group, which is the people doing sports research, to maybe create a new journal where you have more open access. And now it'd be sort of some journals like the Journal of Sports Education and Data Science. Those are more open. And I think we want to create a journal, a sports statistics journal. That's the same thing. So for example, if you want to learn about baseball research, you go to Fangraphs or you go to Baseball Prospectus, or maybe you go to a new journal where you find these articles and, access to be free no matter where you go.
Yeah. Yeah. Nice. A great effort in that. And how about teaching? Do you get any more outlet after teaching for 45 years? Do you get that outlet? Do you get that outlet through the Astros, or is that any outlets to teaching?
Well, I do think that the Astros might benefit if I try to, whenever you present, what I do for the Astros is I make write-ups of problems I've been working on. And I guess one concern when you do that is you wonder if the level of what your presentation is meeting their needs or if they're at the right level. So I think there might be an opportunity to do a little more tutorials for them. There's also a program called Hugo. It's a program to connect professors and high school students who want to learn about different applications. And so I've had the opportunity to work with these students one-on-one. And they're just interested, just high school students who want to do some sort of project related to baseball or basketball. So what I do is I meet with them periodically and they put together a project. So that's a good opportunity too. So I enjoy these special things. I think the thing I miss about being retired is I do miss the interaction with the students, and especially the more of the face-to-face interaction. I retired in 2020, and that was probably a good time to retire because the teaching was more online. Our One Green gravitated to a online format, and it took a lot of effort to teach that way. I didn't see the benefits as much because I missed that kind of student interaction.
Yeah. I imagine now a huge part of statistical education, data science education is how to do it online. Invariably, we're sort of here in the presentation of material. The classroom interaction is one thing, but the ability to do it well online is a whole different skill set, I imagine.
You want to somehow replicate like interactive computing. The idea, one thing that's so nice about packages or software like R is that you can do things on the fly and you make changes and sort of go through a series of data exploration steps, and you want to mimic that somehow online. And that's a little harder. Because really data analysis is not a polished thing where you start from the beginning to the end. Rather, you go forward, you've got some step backs, you think again about what you're doing, you revise and you try something else. So a paper often doesn't really represent the process of learning from data.
Yeah, that's so true. That it's that continually iterative. What is the question I'm trying to answer? How does this data help me? How could a model help me? And the process of that is so different than the final output in many ways, what you're trying to get through there. So the value of sports in many ways is that given people's interest, and now of course sports is huge business. These teams are worth billions of dollars. Contracts are, tens to hundreds of millions of dollars. Do you sign a particular player? How does he work on our team? Is he worthwhile? What's the value? There's huge value in this. But in other areas, so my son is a Division III baseball player, and now their team is incredibly interested in ranking teams because the NCAA now has gone to using what they call the NPI to decide who makes the postseason. And it's entirely an algorithm that they've created that decides which 64 teams make the postseason in this. And so they're incredibly interested in what are the components of it, what are the value of a win, strength of schedule. And this is so important to them now that a number of them are really interested in diving in and comparing the algorithm and actually figuring out what this does and who to schedule and is this good or not. So the world is drastically different than 20, 30 years ago.
Yeah, in fact, it's interesting because I'm a tennis player and I'm currently rated as a 3.5 tennis player. Well, the question is, where does that 3.5 come from, right? It's a rating of your ability. Well, nobody actually, a long time ago, somebody actually watched me play. At that time, I was a 4.
Okay.
But the system to me, it's sort of a mysterious about how they rate players. And, I had a player who was a 4.0 player and he wanted to play in a 3.5 league. So he just asked the USTA as a simple process to revise your rating, and they were quickly agreeable to lower your rating.
Yeah.
And also when you're an older player, they're happy to lower your rating too. And I don't quite understand. It'd be nice if as a statistician, I would like to learn a little more about the mechanics of that. They don't release.
Oh, interesting.
They don't explain, if you play a league and you win every single match, the rating might rise, but I don't know exactly what the algorithm is.
Oh, interesting. So it seems like chess does it much better than tennis, but even golf, in terms of turning in scores and your handicap, and there's a whole science to the golf handicap. We don't get into that. I'm surprised tennis doesn't, quote unquote, do it better.
But of course, it's hard to change the system because it's fun because you get to compete at a local level. And then if you win your championship, you can compete at a state level.
Yeah.
My team in the last fall went to Indianapolis for sectionals. If we had won that level, we would go on to a national. So it's fun to have those opportunities. And I don't think you want to change the system too much because right now it's popular to have those opportunities.
All right. Well, Jim, thank you very much for joining in the interim. It must be so neat for you to have spent a career within statistics and sports, seen the explosion actually of Bayesian methods, computation of Bayesian, sports from being kind of a side interest to many to now it is a full-fledged field and academic pursuit. So thank you for all your efforts and appreciate you joining us here in the interim.
Well, great. Well, thanks for having me. I think I agree. I remember the days when I used to actually copy stats from a book to a spreadsheet.
Yeah.
So things have come a long ways, which is exciting.
Yeah. Yep. All right. Well, thank you all. And thanks everybody for joining us on the interim.